Hi, and welcome to our third lesson on rational functions. Today we're going to be focusing in on application problems. So I just have several types of problems to work through with you. The first one you can read here. We're manufacturing wheelchairs and they are radically different. We have fixed monthly costs of $500,000, and that would cover things like building and utilities and all those things that you have to pay just to be in business. But on top of that, it costs $400 to make each wheelchair. So our first activity asks us to write the cost function. Let's see, cost of things in terms of X. Well, you know you have that $500,000. You pay that no matter what. But then every time you make a wheelchair, and you are making X of them, for every one of those, it costs $400. So there's a cost function for us. Today we're going to talk a little bit about average cost per chair. So if you think about that, cost per share, cost per means divide. Well, then it would make sense to say that our average cost function, and they're calling that C with a bar on top of it, average cost per chair, would be our cost, 500,000, plus 400x, but divided by the number of chairs that we produce. We're asked to find and interpret average cost for 1,000, 10,000, and 100,000 chairs. So I'm going to ask you to pause the video and do just that. So you're going to use 1,000 as X and find out what it costs per chair at 1,000, then 10,000, then 100,000. Okay, let's pause that video. Okay, you can see my answers here. I substituted 1,000 for X in this equation and came up with $900 per chair. When you increase production to 10,000 chairs, you split the cost in half. So now the cost per chair is $450. See, what's happening, of course, is that you're spreading that 500,000 among more chairs. So it brings down the cost of the chairs. When you get up to 100,000 chairs in production, the average cost per chair goes down to $405. All right, if you think about it, the horizontal asymptote for this average cost function right here, if you follow through on the procedure, you're going to divide each term by X. And we know that number over X goes to 0. When you divide by X here, you get 400. When you divide X here, you get 1. That would mean that our horizontal asymptote is at Y equals 400. And what does that mean? What does this represent for the company? Cost per chair can never go below 400. Cost per chair will never be less than 400. No matter how many they make, that will be true. All right, that's that asymptotal behavior, folks. It tries to get there, just can't do it. Our next application involves a formula that many of us will remember. Distance equals rate times time is how I always learned it, and they are using an S to stand for distance, a V to stand for rate, so velocity. It says that we should solve that formula for T. Well, that would mean dividing by V on both sides. And if that's the case, then time must be equal to, and it is distance divided by velocity. All right, that sets us up for this little example problem. We have somebody who drives to work 20 miles one way, each way. The average velocity on the return trip, 10 miles per hour slower than on the outgoing trip, probably because of traffic. Express, it says the total time, I'm going to use a big T, as a function of the average velocity on the outgoing trip, and they're going to call it X. I'm going to say V here. Okay. V is our variable. Well, if you think about it, the total time required would be the time to get to work and the time to get home. And we can write expressions for those things. Our total time, well, the time to get to work, it takes the distance we've said, which is 20 miles, over the velocity that this person is driving, and we don't know that. On the return trip, we still cover 20 miles, but our velocity is 10 miles per hour less. So there is a function that expresses total time based on the average velocity. I want to take that same thing, and now we're going to say, what if we wanted our round trip driving time to be no more than 60 minutes, which by the way is 1 hour? Our function said the total time was equal to 20 over whatever velocity we travel plus 20 miles home at 10 miles per hour slower. And this question says, what if we want to drive no more than 60 minutes per day or 1 hour per day? Then the total time we want to be less than or equal to, although that's not going to change our mathematics, less than or equal to, and again, velocity is the variable here. We don't know. We're asked to find a speed. So we have a rational equation here to solve, folks. Well, I'll give you my strategy. I'm going to multiply both sides by the common denominator of here. Okay, so I'm multiplying both sides by v times v minus 10, and then I think I'm going to end up with an equation that will be solvable. Actually, we'll do that first step. So if we multiply everywhere by the common denominator, which is v times v minus 10, on this side, that 1 times that is just that, so v times v minus 10. On this side, I multiply by v times v minus 10 here. The v's cancel out, and I get 20 times v minus 10. Many of you will remember this. It's tempting to say you're cross multiplying, but that's not really it. We multiply this term by this. The v minus 10's cancel, and we have 20v. All right, I am going to ask you now to pause the video and let's work this thing out. All right, here's my response for that. I did the multiplication, distributed, collected like terms, and came up with a quadratic that needed to be solved. That's a plus right there. I did solve the quadratic over here and came up with an average speed of 45.6 miles per hour. Folks, I did not do 25 minus this because that would give us negative speed, and that would be not from this universe. So to answer the question, the average speed that you must drive has to be 45.6 miles per hour or higher. All right, that's all I have for you today. I'm going to ask you to stop the video, go do the U-Try, and we'll talk about this in school.